Hello everybody, welcome back. Today we have a simply supported beam with distributed load and point load, and we will draw shear force and bending moment diagram for this beam. Let's take a look at the beam first. We have two supports. This one is pin and this one is roller. And there are two kinds of loads. This one is distributed load of 4 kN per meter, and this one is concentrated load of 8 kN. As usual, we start with drawing free body diagram of this beam. There are two reactions here coming from the pin and one reaction coming from the roller. And let's not forget to specify whether this beam is statically determinate or not. So we have three equations: sigma fx, sigma fy, and sigma m equals to 0. And we have three reactions. So since E equal to R, it's statically determinate. Now let's find the reactions at the support. Since we only have one reaction on the x-axis, so AX equals to 0. On the y-axis, there are two unknowns. So let's take the moment about point A. And I will take clockwise is positive. Now let's take the summation of forces on the y-axis. So we have AY minus 4 by 10, which is 40 here, minus 8 plus 16 equals to 0. So calculating that will give us AY equals to 32 kilonewton. Now we have all the reactions. Now let's move on and draw the shear force diagram. We have positive 32 coming from AY. So let's go up by 32 kilonewton. Now we need to go down by 4 multiplied by 10, which is the amount of concentrated load. So 32 minus 40 will give us minus 8. So this is minus 8. Now nothing is changing here. So we go the zero slope. Here there is minus 8. So we go minus 8, which is minus 16. And here nothing is changing. Go straight line. Here we have the amount of By, which is 16. Don't forget to put the values. Now to calculate the area under the shear, we have to find this distance first. I will call it x. Therefore, this distance is equal to 10 minus x. And to find x, let's use similar triangle method. So we have x over 32 equals to 10 minus x over 8, which will give us x equals to 8 meter. Now we can calculate these areas since we have x equals to 8 and this equals to 2. So here 32 multiplied by 8 multiplied by half will give us 128. And this one here is equal to minus 8. Taking this rectangle alone equals to minus 40. and this rectangle is minus 80. So what are the units here? The units here are kilonewton meter. Since we have all the areas, we are ready to draw bending moment diagram. And here there is a triangle. So the shape here will be increasing curve because of this plus sign. So it will be like this. This is 128 kilonewton meter. And now this tiny triangle has the area of minus 8. So we will go 128 minus 8, which is 120. This is 120 kilonewton meter. Now here we have a rectangle, which means the shape here will be a line with decreasing slope. So we will go 120 minus 40, which gives us 80 kilonewton. And here there is another rectangle with the area of minus 80. So finally, we have a line here going to the zero. At the end, we have the bending moment diagram and the shear force diagram close at zero. So that's good. Finally, if you are required to specify the maximum moment, it's plus 128 kilonewton meter. Thanks for watching. See you in next videos.